Good morning. I'd like to welcome everyone to Sarasota County Fire Department training. I've been invited by Chief Easton to do some training on lightweight construction and the collapse potential and also the truss bill. Before we get into that, I'd like to introduce myself. My name is Leigh Hollins. I'm a battalion chief in the training division at Cedar Hammock Fire Rescue, which is in Manatee County. I've been involved in the fire service since 1976 as a volunteer in New Jersey. I moved to Florida in 1977 and was employed by Whitfield Fire Department, which is along the Manatee-Sarasota County line. And not many people knew that they had paid firemen back then, but they did for a couple of years under a training program. And in 1978, I went to the city of Bradenton Fire Department and worked there for 5 years. And I've been at Cedar Hammock since 1983 and getting ready to retire in a couple of years. So it's been a nice run, and I've been involved in training about 15 years. So with that said, let's go ahead and take a look at today's program. Firefighter safety operations in lightweight buildings. So we're going to be covering several things today. Take a look at first a little dedication here. I'd like to dedicate this class to all those that have given their lives so others may live, and also to the 343 brave firefighters at FDNY who gave their lives on September 11th of 2001. We're approaching the 10-year anniversary, and I certainly always like to dedicate the class to those that have given their lives for others. So the objectives today, we're going to talk about building construction types. We will talk about building collapse in very general terms, and then we're going to pinpoint down on the specific issues that we will be referring to today. Actually, the program today will run about 2 hours, a little over 2 hours, and what we'll do is we'll break that into 3 segments of approximately 45 minutes. So about every 45 minutes, wherever there's a good break point, we'll take a break, and then we'll go into the second session and then the third session. Building construction methods, and it's my understanding a couple of y'all have a construction background, somewhat familiar with building construction methods. So this class we're going to be doing some interactive discussions on certain questions and topics, so hopefully you can provide some input there. Legacy versus lightweight construction, we will be dealing with that issue throughout today's class. Legacy being the old style of construction, and lightweight, of course, with some of the new type of construction of today. Also, what comes into play are the furnishings, the legacy versus the lightweight furnishings of today, and man-made materials specifically. The Aldridge-Bang Firefighter Safety Act, commonly known as the Truss Bill, which deals with these signs here, and how that applies to operations. And what that's all about, I'll tell you all about that at the end. We're going to kind of go through a lot of construction issues first that lead up to this particular truss bill and how it affects fire operations and what you need to know as a firefighter, as a fire officer, and as an incident commander. Fireground operations, we'll talk quite a bit about that throughout, but at the end we'll get very specific on exactly each of those 3 positions I just mentioned, and we'll evaluate how that applies to you specifically. I'd like to start off just by going over the various types of construction. This is the National Building Code. There's 5 types of construction. This isn't anything that you should have to have a lot of detail about, but as you advance in your career, it becomes very important because different types of buildings are going to act a different way under fire conditions. So as you advance up as acting officer, as lieutenant, as acting battalion, and running a scene, incident commander, it's going to be more important as you advance in your career. Type 1 is what's called fire resistive construction. This is what you're going to see mostly in your downtown Sarasota area. We're talking about high rises here. Structural members are non-combustible or limited combustible materials. Primary hazard are the contents. Ability to confine fire is usually compromised by openings. This is usually a type of building that is made of steel, glass, and concrete, and the steel is typically protected in some fashion, whether it's boxed in with drywall or if it has fire retardant sprayed on it, things like this. But fire resistive, type 1. Type 2 is called non-combustible. It's similar to type 1, only the degree of fire resistance is less. These steel I-beams and so forth may not be protected. It's still made out of non-combustible components, steel, glass, concrete, block, but these components are not necessarily protected. So it's kind of the next class down from type 1. In some cases, materials with no fire resistance may be used, not combustible materials, but like I said, steel I-beams and things like this. That would still, fire would have a dramatic effect on because it's not protected. Also, the primary hazard would be contents in these types of buildings. Heat buildup during a fire may cause structural supports to fail. Type of roof material may contribute to fire extension, such as if you had a membrane roof, where fire gets up in the roof area and starts running that membrane. Different types of build-up gravel roofs that have tar and so forth, that may be a factor in a non-combustible building that's on fire. Type 3, ordinary. This county has many buildings of ordinary construction. This is basically your downtown areas that are not your high-rises, like the Gator Club and those type of areas along Main Street, where you're looking at mortar, brick, some steel, also wood used. That will be dimensional lumber. It will be 2x12s, 4x4s, 6x6s. There's not heavy timber, but lumber is used in these type of buildings. Exterior walls and structural members are non-combustible or limited combustible. Interior structural members completely or partially of wood, but it will be dimensional lumber. Wood used has similar dimensions, smaller dimensions than heavy timber, as I already mentioned. A primary hazard is fire and smoke spread through concealed spaces. So you still have an issue with fire spreading through these spaces. The difference that we're going to compare, because this is the legacy construction, so to speak, and then we'll compare that with the lightweight, and you'll be able to recognize the difference. Matter of fact, I know that most of you already know the differences. We'll get into those in a little bit and do a little comparison. But that's your downtown older areas, is ordinary type 3 construction. Next you have heavy timber. It is exactly what it says there. That's what it's made of. The main structural components are going to be heavy timber. These are typically the mills and factories and so forth up north, but you probably have some of these in your county. Certainly not a tremendous number of them, but you probably do have some heavy timber buildings in your area. These are the type of buildings that you see on Firehouse or fireengineering.com or in the magazines, where you got warehouses like that and you got every window lit up. Those would be a heavy timber type of construction method where everything got going in there and a lot of components to burn there. Exterior and interior walls, associated structural members are non-combustible or limited combustible materials. So in addition to heavy timber, you're going to have some of these steel I-beams. You're not going to have the lightweight bar joists or any lightweight components like that. You're going to have heavy steel in addition to the heavy timber. In other words, they may use the timber as columns, and they may use the structural steel as beams, something like that. Other interior structure members are made of solid or laminated wood with no concealed spaces, as I just mentioned. Wood has large enough dimensions to be considered heavy timber. The primary hazard would be the contents of the structural members themselves. Like I said, you get a 10 by 10 wood beam that's 50 years old and it's exposed to fire. That's going to be plenty of fuel. It's going to take a long time to burn through, but it's going to provide plenty of fuel for the fire. Because of the amount of heat given off by the structural members, the building may pose serious exposure protection problems as well as collapse problems down the road as the fire progresses. So that's heavy timber, type 4. Type 5 is wood frame. All woods and structural supports are made completely or partially of wood of dimensions less than heavy timber. Now notice it doesn't give you, okay, this is heavy timber, 8 by 8 and this is not. But that is a call that is made by the building official looking at the plans on how a building is constructed. Presents unlimited potential for fire spread, may present a serious exposure problem, especially if exposures are of similar construction, which they typically are. And if it's a multi-story, like the bottom left picture you see there, a lot of times that's referred to as a vertical lumber yard, especially when it's under construction. Everything's open, everything's exposed, and you can have severe, devastating fires like Tampa had several years ago at an apartment complex under construction. They had like a 5-alarm fire where it just went from one building to the other. Everything was open, exposed, and of course, at the time, there were water supply problems. That's something you'll typically find at a construction site. Now, several years ago, everything was going gangbusters with building in Sarasota, Manatee County. Kind of calmed down now, but you could have these complexes with 30, 40 apartment buildings, 3-story or so, going on. And what about hydrants? You know, are the hydrants in service yet? So that's something the fire prevention folks need to deal with, because you get a complex of buildings like that going and you don't have water supply, you got major problems. So some of the fire service also say there should be a type 6 construction for light frame, lightweight. These are lighter components, but a wood frame building that is built of dimensional lumber and framed out like the old days, which we're going to get into, would be different. That would be wood frame versus if it's all lightweight components like some that we're going to look at. Some advocate that there be a type 6 construction, but officially there's only 5 types. Okay? So it's not real important because, of course, if you get into the building code, there's a 2-page definition of each of these types of construction. But just these bullets here are real important to know when you roll up on something. Okay, we got an ordinary constructed building here. And like I said, I'm going to give you a little comparison and get you involved here in a couple minutes so that you can see how this affects your fire operations. All right, let's talk about the issue of building collapse. That's going to be our umbrella, okay, building collapse. And we're going to refine this right on down to where we want to talk about today. Now, let me add, well, first of all, I'll divide it into 2 different types. One is going to be building collapse due to other than fire, and then there's going to be building collapse due to fire. So let's talk about briefly, and then we won't talk about it anymore. Let's talk about collapse not due to fire. What are some of the reasons that a building may collapse other than fire? Anything? Yes?
Wind.
Wind, be it direct straight line wind. It could be tornado, could be hurricane. So wind has multiple. Anything else? There?
Maybe poor engineering.
Okay, poor engineering where you have a structural failure, specifically under construction, which happened some years ago, I believe, at the parking garage of the hospital here in Sarasota. I believe that was what caused that collapse. Yes?
Age of the building?
Okay, the age of the building, and we're going to take a look at a building in a little bit that's been sitting vacant in Detroit for years and years, and you'll see that gravity's going to have its way with that building pretty soon. So absolutely, yes. What else?
Collision from some other object.
Okay, large vehicle runs into a building, brings it down. Airplane goes into a building. So there's a lot of different reasons. Gas explosions. Somebody planted a bomb. I mean, we can go on and on. There's a lot of different reasons for a building to collapse other than fire. Now, when that happens, you typically arrive when in that event?
After the event.
After the event. All right? Now let's talk about buildings that collapse due to fire. Okay? We all know about that. Now what's the major difference, Chief?
No, it's during the event.
You're going to be there. This is not some rural, of course, Sarasota County does have some rural areas, so I probably shouldn't just broad brush that. But in most all areas of your county, you're going to be there. If the building collapses, you're going to be there. In some very rural areas, like I say, east part of your county, or in some of the rural areas of North Florida, Georgia, North Carolina, a lot of areas of this country, that may be something that commonly happens. I have a cabin in Fannin County, Georgia, It's a county of 10,000 people in far north Georgia, and it's all volunteer fire department. So they get a call for a 3-story, 3,000 square foot wood cabin on fire in the middle of the night on a Saturday. By the time they get their firefighters to the station, first of all, the call comes in, you got your delay with all that, then they got to tone it out, and they get to the station, and then they get in their 1968 pumper and drive up Joe's Mountain at a 20-degree angle. You know, by the time they get there, it could be 20, 30 minutes after the fire was called in. So for them to pull up and have a cabin fully collapsing in when they pull up is fairly common. That's going to be rare in Sarasota, except in maybe the further east areas, but I think that would be a rare event. So that's the main difference. Keep that in mind. If a building's going to collapse due to non-fire conditions, you're going to get the call after it happens, and you'll be able to deal with that. If it happens due to fire, you're probably going to be on the scene, and that's what this class is all about. This class is all about making sure you're not in or on that building when it collapses, because if a fire is into the structural components of the building for long enough, it will collapse. And I'm not here advocating that we not be aggressive firefighters, and as we go through this, you'll see what I'm talking about. But that is the main point of today. There's the two main points are that one, and there's one other word we'll look at here in a couple minutes, are the main point of the next 2 hours of instruction here. These documents are from NIOSH, the National Institute of Occupational Safety and Health, and if you go to Google or Yahoo or whatever search you use on your computer and you look these documents up, you definitely should take a look at them. There's a lot of good information on these documents. The one on the right here, Preventing Injuries and Deaths of Firefighters Due to Truss System Failures, is a 32-page document. It has case histories, it has pictures, it has diagrams of the various trusses. It's real good stuff. So take a look at that. And the one on the left, Preventing Injury and Death of Firefighters Due to Structural Collapse in General. And these documents are something that you should print out, have in your station every once in a while, take a look at them. Great, great information. But what I want to glean out of this is death versus injury, because most of us fear the letters LODD as line of duty death. That's like, wow, that's the worst it can get in our line of work. And it happens to about 100 of us every year across this country. But I'd like you to take a look at injury. Now, I already kind of gave you the answer. Most of the time I'll ask the students, if you will, that how many firefighters are killed in any given year. And several of the students will know it's about 100. But if I ask you how many firefighters are injured on a job in a given year, that's not really a statistic that's thrown out there unless you really study it. So that to me is equally important. So Mike, is it?
Yes, sir.
Mike's been on the job for 14 months. How old are you, Mike?
26.
Okay. Is this something that you looked at for a long time to get on the fire department?
A couple of years, probably 5 years. 6
About
years.
5, 6 years looking at it, going to school, preparing, saying this is what I want to do.
Yes, sir.
Is it in your family?
Yes, sir, my uncle.
Okay, his uncle? That's typically what we see here. All right, so it's something that you really strive for, you work hard for, and here you are. Been on the job 14 months, and it's great, right?
Yes, sir.
Okay, that's what I like to hear. That's what most firefighters tell us. I mean, it's just a great, great career. So being at the other end of that career, I can tell you that the whole ride's going to be pretty good, okay? Except if something like this happens, okay? So let's talk about injury. Let's say you were at a job tonight in a 3-story apartment building and you get severely burned over 60% of your body and you're flown to Tampa General Burn Unit. Mike, what do you think you're going to be wishing for in the next few days?
I'm not sure. I won't be thinking much, probably.
Do you think that during this treatment that you're probably going to wish you were dead?
Yeah, possibly.
Possibly. People that are severely burned and they're in there scraping your skin off is probably going to cross your mind, okay? And then we have the issue of if you survive, what about afterwards? Can you do your job?
Right.
Would you be devastated if you survived that event And a year later, it was determined that, yes, you survived it, and you got the scars to prove it, but now you can't come back to the job. Would that devastate you?
Yes, sir.
Okay. Who knows what his life would be like? So in some cases, injury can be worse than death, because death would almost be an easy way out on that deal than being burned that bad. So I just want to bring to your attention, don't just concentrate on line of duty death issues and dying on the job as that's the worst thing can happen. It can be almost worse if you survive. So we want to do everything we can to prevent that from happening. And that's what we're here for. All right, let's take a look here. Basically what we're going to be talking about is type 3 ordinary construction and type 5 wood frame construction. The other types we're not really going to be dwelling on because that's a whole other issue. You could take a 40-hour class on building construction to teach you all about those other issues. But, excuse me, we're going to be talking about type 3, which is on the left, right? We got block, we got wood being used, we do have some lightweight trusses, we have some OSB board being used for the wood roof decking, and on the right, this is all wood frame. What about the brickwork here? What about the brickwork on that building? Is that real brick, you think? This was built 10 years ago. No, it's a veneer. It's just stucco. And then they run these grates through it and make it look like brick and paint it up a little bit. So, we don't want to be fooled by that. That's why it's important to look at these construction sites when they're going on, when they're being built. You can look at that and go, no, we know that's all wood frame building. So we're going to be talking about a type 3 and a type 5 building here. All right, and we're going to be talking mainly about floor and roof support systems because that's where these lightweight components are coming into play, and that's where you're going to have problems with people falling through or having them fall on them, firefighters being killed. And the lightweight components are a major part of that problem. So if we look at this particular slide here, we know that building on the left is ordinary constructed building. It's built of stone, mortar, brick, some wood components, probably some steel in there. The one on the right, that will be an all wood frame building. But this building was built probably in the 1930s or 40s. And that one's probably built maybe a little before that. So we kind of know those buildings that they're going to stand up fairly well under fire conditions. Do you agree? Versus the buildings of today. The reason is the way they're constructed. When we're looking at the wood components, the floors are going to be what we call dimensional lumber. 2 by whatever, 2 by 8, 2 by 10, 2 by 12, 2 by 12s together, whatever. That's how the floors will be supported in those older buildings, specifically the residential buildings. And then your roof structures will be dimensional lumber. This particular one, you see some roof rafters here. It would go up to a ridge board. Everything would be nailed together, and it would be built out of this dimensional lumber. You got a little knee wall here holding some support up, but that's the way buildings used to be built when they're using wood components in the building. Now, if you look at the post-70s, now you have lightweight buildings. So the building on the left, I can almost guarantee you that I can go in there, pop a ceiling tile in that commercial building, and I'm going to be looking at lightweight steel bar joist trusses, or I'm going to be looking possibly at lightweight wood trusses put together with gusset plates to hold that flat roof in place there. Right? One of the advantages of these type of components are open spans without any columns to hold them up to get in the way of the retail area of the store. What else do we notice on that building on the left while we're talking about it? What else is a problem operating that building? No windows. There's no windows on that building except in the front. So that's going to be an issue for us also. Now this fine house on the right, which happens to be the Hollins residence, I know for sure what that's made of. That thing's made from wood top to bottom, and wherever they could use OSB board, they use it. So it's not even plywood. That was built in 1991. It has some dimensional lumber used to support the floor, and it has lightweight trusses supporting the roof. So If we took a look at my house here, built in 1991, and this old house here, built probably in the 20s or 30s, I can ask the lieutenant here, as far as operating in either of those buildings with a similar fire, you got a fire in the back bedroom, okay? What do you think would be your main differences to you as an engine officer with those fires in the old versus the new?
I would think in the older building, I have a longer period of time before I have to worry about collapse or fire getting to the attic or spreading anyplace else. I got more time.
Time. With the exception of a multi-story older building with balloon frame, where it may spread up, but you're dealing with dimensional lumber, and time is going to be the main issue. You're going to have more time to operate. The fires of today are going to be much different than the fire of yesteryear, and the fires in today's buildings will be different than in the buildings of yesteryear. So we already know this, especially anybody that has any time on the job. We realize this, and we know this is going to burn quick. And we're going to see a video here to show this. All right, some of the components that were used in the post-70s are the engineered I-joist, and we're going to talk about that quite a bit because it's a very popular structural component, and it fails very, very rapidly under fire conditions. You all are familiar, I'm sure, with the parallel cord truss. Now we're getting into engineered I-joists that have, some of them have knockouts to run utilities, where you can knock out a two-inch hole to put a half-inch piece of wire through, and we're going to get into all that. And then you have this brand new XJ85 by Georgia Pacific, which has all these openings already in place. Now, I could tell just by looking at it that even if I was given a choice of the one on the left there or the one on the left there, I'll take this one because it doesn't already have holes in it. Because the holes are not only going to be an issue with strength, the holes are going to be an issue with fire spread also. So these are things that if you've studied this and looked at these issues or read articles or read Brannigan's book, that we're already on to. So this would be good reinforcement. Look at this one on the right. This is taken at Northport Fire Department in their training room. All I had to do was look up. There they were. This is a parallel cord truss hybrid. What's that made of? What are the webs in the middle made of?
Metal?
Yeah, tubular steel. Not even solid steel. And then what are the cord? The top and bottom cord is made of what?
It could be wood.
It's wood. It's a hybrid. You got wood and steel together in this particular truss. It's all lightweight stuff, and we're going to look at an incident that failed, that these failed at, that killed a firefighter here in a little bit. We learned by all the mistakes that others have made. Look at the one on the left here. I don't even know what to call it. Is it a joist? Is it a truss? I don't know. It's a stamped steel parallel cord joist, I guess, but it does have a system of triangles that make up the engineered support on that. So we're going to talk about exactly what is a truss. And then you have this truss on the right, and now look at, you don't even have gusset plates holding it together. I don't know if that's better or worse, but these are finger jointed and glued together. So you don't even have the gusset plates, the steel plates anymore on some of these joists. Then you also have steel trusses on the left there. They don't, the bar joist is very common, like you go to Walmart, look up, or Home Depot. You get the parallel cord steel bar joists in most cases. But there's all kind of different metal truss systems that are being used out there today. This is a channel steel. That's not solid. It's just a channel steel, like you use a steel stud building a home. It's that type of C-channel steel. Or it may be a four-sided, but it's hollow, it's lightweight, it's light frame. You got your typical wood gable truss made of wood and gusset plates holding that together, which we've seen for years and years and years now. So these are the lightweight components that are being used. Even these systems are lightweight, light frame. On the left you see the steel bar joist, and on the right there's a steel angle iron truss. Now, before I go any further, I want to let you know, first of all, what is a truss for our class? What are we talking about? A truss is any type of structural component that holds up a floor or a roof that is made from a repetitive system of triangles. Right? That's going to be real important, especially to the chief here, because the truss bill only covers trusses. It does not cover these engineered I-joists because they are not trusses. And in one of the films we'll look at, one of the instructors is going to say that that engineered I-joist is a truss. It's not. Just remember, a repetitive system of triangles. If it's a repetitive system of triangles, which gives that component its makeup and strength, then it's a truss, and it will be covered by the truss bill that we'll go into detail at the end. But not all the components we're looking at will be part of this truss bill. So with that said, let's take a look at a video here. We're looking at legacy versus lightweight construction under fire conditions. This is up in Loudoun County, Virginia.
Two house fires, both in Leesburg, Virginia, but with two very different outcomes. One house burned to the ground, the other didn't. And the reason may have to do with the age of those homes. And Dave Cedar explains, in this case, newer isn't always better.
This is what firefighters in Leesburg saw when they pulled up on Seton Court this morning. They didn't have a chance to try and save this house. It is believed to have started on the outside and spread up into the attic. Firefighters in Loudoun County and across the country say this is often typical of the fires they see in newer homes built over the last 2 decades. This is what is considered lightweight construction.
Lightweight construction that we're seeing now is made of lighter materials.
Loudoun Fire Marshal Keith Brower says the lumber supporting the roof and floors in the newer homes are connected with plates that separate quickly in a fire.
The floors collapse, the roofs collapse at a greater speed than in the past.
An hour earlier this morning, firefighters were at a fire in this Leesburg home 2 miles away. It is of older construction, built in the late 60s or early 70s. While this fire started on the inside, it too spread up into the attic.
In older construction, the fire is typically going to stay in the room of origin for a longer amount of time.
Firefighters say this is the reality they're dealing with. With the older homes, even with a fire in the attic, they're often able to get inside and stop the fire so there's something to salvage for the homeowner, and the house is still standing. But with the newer construction, all bets are off.
We used to think that we had anywhere from 8 to 10 minutes that we had a safe margin to go in and begin attacking the fire.
But Brower says the fire spread is so fast and the potential for collapse so great in newer homes that firefighters may only get a couple minutes inside to try and stop it spreading before giving up. It also means the people who live there have a shorter time to escape.
Radiant heat travels in a straight line.
And this morning showed another typical problem. Homes as far away as 150 feet had vinyl siding that began to melt. Brower says a delayed alarm can mean more than one home is burning by the time firefighters get there. Dave Cedar, 9 News Now.
Home builders have long said that they use those lighter weight materials and construction methods to make houses more economically. In Maryland, some jurisdictions require sprinklers in all new single-family homes. That's a battle between home builders and the fire service that is still going on in Virginia and in other states across the country.
And also that reporter, Dave Cedar, he's a volunteer fire chief or division chief somewhere up in St. George's or one of those counties by Washington, D.C. He's got a great website, Statter911.com. I think it's S-T-A-T-T-E-R, 911.com. Great website. All right, well, that's just giving you a little precursor of the problem that we'd be talking about here for a half hour. And the other component of this will be the furnishings. And the furnishings of the old, which were made of of natural materials, such as wool, cotton, wood, things like this, have been replaced with the polyesters and nylon and rayon and these man-made components that furnishings are made of, from the carpet to the drapes to the couches, the end tables, whatever, plastics of all sorts. It's had a dramatic effect on fire conditions in the home versus the old natural materials. So let's take a look at a couple of pictures here. On the left, you see a natural furnished home made out of the materials that I mentioned. Leather, wool, cotton. And on the right, you have the synthetics. A lot of these synthetics are made with what type of product? With polyesters and nylons is made from what?
Petroleum.
Petroleum based. So we know what happens when that burns. And we've all seen it. All these plastics and so forth, all petroleum based. So what they did with this test is they put a 1-inch birthday candle on the sofa. You see it right here? And then they put one here, same, timed it out. And there's after 110 seconds. Now, if you look at 4 minutes, you see the dramatic difference. So this is real stuff. This is how it happens. And that's why if your family has been in the fire service for years, your grandpa or your dad might tell you that fires aren't any hotter today than they used to be, and don't give me that, we were tougher than you guys and we didn't have air packs and all that stuff. Well, they could operate in a fire like that after 4.5. Yeah, you don't need an air pack for that, right? But you ain't going nowhere with this one. You're coming in on that and you're blasting that fire with a solid stream and you're getting knocked down to the carpet on that deal, right? So same amount of time here, different furnishings. So between the lightweight components and the furnishings of today, it's like the perfect storm right there, because the lightweight components are not going to stand up to this type of a fire. And when we get towards the end and we do the summary, the main point, as we have already discussed, is going to be, is the fire attacking the structural components of the building? If it is, it's subject to collapse, and if it's not, it won't collapse. If this is a room and contents fire here, and this is contained within this room and it does not get into any of the studs or the joists or any of those other structural supports, that building will not collapse. It's that simple. So the chance of that occurring, because now with this type of room, what are the walls and the ceilings made of in this room? Drywall. They're made of drywall. That drywall is going to fail in about 15 minutes under these fire conditions here. Whereas the room on the left, even if it did get to that stage of rollover, flashover, that room over there, that is going to be a plaster and lath type of ceiling and walls. That'll last up to 60 minutes before that fails and allows the fire to get to these structural components. So major issue dealing with the contents of the home or the commercial space that is on fire. Now here's the one that I referred to earlier, that when we're talking about age. Okay? There's nothing but age that is doing this to this building. Gravity is trying to pull this building down since the day it was made. And if left long enough, it will happen. So the main issue will be structural components. Are they exposed to fire? And for how much time? If I could say one word to describe this whole session today, it's going to be time. That's going to be the key. Time is critical. Time is your enemy. So, I've already kind of alluded to it, but let's jump in it a little bit deeper. Other than time, the main issue is going to be, is it a building fire, meaning the contents are on fire, or is it a structural fire, meaning those structural components are burning? Okay? So the incident commander, what is it that you're always wanting to know when you got crews in a home knocking a fire down?
What kind of extension do I have?
What kind of extension? That's why. Because he knows that if it extends into these structural components, ooh, we got a problem now. This building could collapse now. If it's just, hey, we got a room of contents, it didn't spread anywhere, the building's not falling down. So this is what's important. Now, if you read Brannigan's book, Building Construction for the Fire Service, and Mr. Brannigan passed some years ago, but I had the pleasure of meeting him and talking to him. And now the newest edition is out, and it is also co-written or edited or whatever the term is by Glenn Corbett, who's a professor at John Jay College, and he's a firefighter up in New Jersey. And he's a whiz with all this architectural, building construction, design, engineering, and all that. So this book has been updated and it's certainly still valid. And in every issue, the same thing has been in there. And that is a suggestion for fire departments across the country that you designate the difference between a building fire and a structure fire. When you guys are toned out, the building down the road is on fire. What is it toning you out for? What is it saying over the speakers? What? Structure. It's saying structure, same in Manatee County. Actually, I'm trying to work with the chiefs to try to maybe take another look at that. And one of the resistance issues I met was, yeah, well, that book was, you know, originally written 40 years ago, and the guy that authored it is dead now. And well, you can't have that argument where Glenn Corbett is on board now with the newest edition, and it's still in there. So you might want to revisit that at some level and say, okay, we'll tone it down as a building fire, and when the chief gets the report, be advised we have fire in the attic space, or be advised we have fire in the concealed area between floor 2 and 3, or division 2 and 3. Then you hit the alerts that, okay, we now have a structure fire. Now that doesn't mean that you come running out like rats. It just means that now the incident commander needs to be taking a look at your time marks, which I assume you all use some kind of time marks to let the incident commander know how long you've been on scene or how long since the alarm. All right? Start thinking about that, looking at the conditions, getting the reconnaissance reports from outside and inside, and making a decision. Are we going to keep going at this? Are there people to be rescued? There's your big one right there. If the answer is no, okay, well, wait a minute now. This is a building. Let's take a look and see what we want to do, because we now have a structural fire. And if you got a structural fire, the building could fall down, depending on how long they've been exposed to these components, what type of building it is. When we talk about trusses a little bit later, we'll get into a little bit more of that about, okay, well, how do we kind of know how much time? And there's some things that those that study and have experience can use that experience to everyone's advantage. Take a look at this. All right, here's just a couple pictures. A couple pictures is all. That building on the left, is that a building fire, contents only, or do you think that's a structural fire? I don't know how well you can see that.
Structure.
It's a structural fire. Why?
Because it's coming out under the eave.
It's coming out under the eave where we have, it looks to, you can't really tell if it's a single story or a two-story building. There's some structural components being compromised there. Just one little picture. About the one on the right. Yeah, don't know. You can't tell from that. Looks like you get in there and knock that thing down from, you know, push it right out that window. There's really no indication there that that's a structural fire. We're looking at one picture. The incident commander would have reconnaissance reports from officers on the scene on what do we have here. Okay. What about the one on the left there? What do you think? Is that a structure fire or a building fire? Just looking at that one picture.
Structure.
Yeah, I'd pretty much guess on a structure on that. I certainly would lean towards it and hope that any error would be with my decision. But yeah, when you got that front lit up like that, and now you got fire blasting out them second-story windows, you can't really tell if it's coming out of the eaves up there or not. But it probably traveled up a stairwell and went into some rooms that had their doors open. But I would lean towards that's a structural fire, and we're going to be real careful going in on that fire. The one on the right, pretty much can tell right off the bat. There's already been some collapses, all kind of debris and so forth. Now, where are those firefighters positioned?
Outside.
Outside, but where in the building, or outside of the building in a safe zone, right? Where are they standing? At a corner. If the building collapses, the corner is not going to come out at them. Okay, so they're in a safe area right there, or as safe as it gets if you have to do that type of work. So let's take a look at a video here, and we'll listen to a couple comments that are made, and we'll review that, and we'll go just a few more minutes, and we'll take a break.
Attention Station 102, final call for Captain Robin Brocksterman and firefighter Brian Shira. They've completed their last alarm and have returned to quarters for the final time.
When the alarm sounds, firefighters react and rely on their equipment, their training, and each other for their survival. Their job is inherently dangerous. That reality sunk in 6 months ago when Green Bay firefighter Arnie Wolf died in a house fire.
There's a feeling amongst the firefighters that yes, something needs to be done. August 13th, reality set in for the Green Bay Fire Department. It can happen here. It did happen here.
Joe Brinkley Shoodware was Wolf's partner that day on a routine call to an East Side fire at an upscale home on Edgewood Drive.
Oh, it's just light smoke showing. It's nothing.
Shoodware and Wolf go in.
About 5 feet later, we were in the basement.
They became trapped where the fire started.
I heard one Mayday on the radio. That was him. But I never heard his pass alarm go off. I never heard him screaming for help.
How long had the fire been burning? How long did they have before it could collapse? There's no time to second guess when firefighters are missing. Captain Jay Sellison and Eric Johnson are two of several Green Bay firefighters on a committee conducting an internal investigation of the Edgewood fire.
That type of construction, 4 to 8 minutes, and it's going to give way. Whereas in traditional construction, we would have 20 minutes, 30 minutes before there'd be an issue. Modern fires are burning so much more violent, so much hotter, so much faster.
They figured it was about 2,000 degrees in there.
It's up to code, Sellison says, but is dangerous to firefighters nationwide.
It has been 6 months since the fire on Edgewood Drive. The home is gone. But what happened here is still fresh in firefighters' minds. Wolf's death a constant reminder of what no one wants to happen again.
What are they waiting for? One of us to die. And now somebody's died. So now what are they going to do?
Okay, a couple things I heard in that video. August 13th, reality set in, that guy from Green Bay Fire Department said, meaning that it can happen here, it did happen here. And that's what a lot of people are complacent with. People think it won't happen to them or it won't happen to their department. Well, that's you don't want to take that bet. Right? It can happen anywhere. How many of you ever heard of Keokuk, Iowa? Right? I only heard of it, why? Because 3 firefighters were killed in the collapse of a building there. Or Gloucester City, New Jersey. I'm from New Jersey, never heard of the place. A few firefighters were killed in the collapse of a wood frame building. So when people in Chicago hear, Beneva Road in Sarasota County, like, where is that at? It doesn't matter. It happens everywhere, not just in the big city. The big city gets all the publicity, and a lot of the times there's multiple deaths in those fires in larger cities. But it happens in smaller towns all over the country. So don't be fooled into that like it can't happen here. And what did the female firefighters say on arrival? Just light smoke showing. It's nothing. How many fires have you been on like that? You roll up, light smoke showing, or no smoke showing. Now, if you had a fire in the house that I grew up in along the Jersey Shore, which had all those jealousy windows all over the place, and when it's windy, and the normal windows were the double hung wood frame double hung windows with the lead weight in them and the rope that was a counterweight, and when it was windy, those windows were shaking. And the jealousy windows, if you stood on the front porch near the jealousy windows and it was windy, you get real cold because the air comes through them. Versus a house that's now made with the hurricane glass and so forth in any of your newer communities around here. What would be the difference in those two houses if you rolled up on the same exact sofa burning in the middle of that home? What would you see my Jersey Shore house, that sofa's burning in that home on arrival? What are you going to be looking at?
Smoke.
A bunch of smoke, because it's going to be coming out all those jealousy windows because it wasn't well sealed. Now the new home out in Bee Ridge Acres or whatever's out there in your zone that was built 4 years ago, all hurricane glass, it's all energy efficient. The same exact couch is burning in the middle of that home. What are you going to be looking at on arrival? Yeah, probably nothing shown, or light smoke showing, it's nothing. So don't be fooled by that. You can have a pretty good fire burning in these homes that are built today, energy efficient homes, and not have a whole lot showing. So keep that in mind. Another difference between the older homes and the newer homes will be what you're going to look at on arrival. So, with that said, we will go ahead and we will take a break, and then we'll come back and we'll do session 2. Okay? Anyone have any questions so far? Okay, thanks a lot.